Okay, so you've actually already gone over the vocab for this, hopefully. Identifying solutions of linear inequality. So we're taking this whole concept of linear equations and we're going to add inequalities to it. They look really similar. If you look at this here, other than y equals x minus 3, which is really easy to graph, right? We have y greater than x minus 3. And we'll start our discussion then here in checking to see, identify some solutions, right? So what that means is take some points and plug them in. Take the 2 and plug it in for the y. The 1, plug it in for the x. And is it true? So in this case, if we do that, we plug it in. We can see it done right here. 2 is greater than 1 minus 3. Well, that's true. 2 is greater than negative 2. So that is a solution. And if you remember the discussion we had in vocab, what this really looks like, just a second, I'll pop in sort of a faked up graph. So this is a graph of y is sort of equal to x minus 3. It's obviously the y-intercept negative 3 and then a slope of 1. But notice it's a dashed line because, as we discussed in vocab, there's no equals part to this, so you get a dashed line out of the deal. Now, the second part of that is graphing the idea of the greater than less than part. And which way is y greater than? That's really what you ask yourself here. Which way is y greater than? Y is bigger going up. So you shade this part of the graph. Okay, well, I just kind of wrote over that bottom part. But anyway, so what that's saying is the point 1, 2 inside of this. Actually, it is. If I go over 1 up 2, that's inside of my shaded area. So yeah, it's a solution of it. So likewise, plug in negative 3, negative 7 into this equation and see does it work. And we find a little bit of math, fun. Negative 7 is not bigger than negative 6, so it's not a solution. And if we kind of mock that up, right? Negative 3, negative 7, so somewhere down here. So where this line goes like this, right? This is going to be outside of the realm of the graph part of that. We're going to check that in the next one here, just a second. So you heard that running water in the background? Yeah, my son noticed I had to fill up a glass of water as I'm trying to, teach you something here. So you can thank him for that weird noise. Okay, so let's do one of these for ourselves here. Is this a solution of this? So we're going to plug that in. So we're going to take y is less than or equal to 2/3 x plus 4. And we are going to plug in our 6 and our 3. So we're going to get 6 is less than or equal to 2/3 times 3 plus 4. 6 is less than or equal to, let's see, 3 over 1, a little canceling, 2 plus 4. So 6 is less than or equal to 6. Well, that's true. Now, it's only true because I have the equals part. If it wasn't there, then it would be not true. But anyway, so there you go. That one does work. In fact, it lies right on the line itself. And remember, when this one's graphed, I've kind of mocked that up for you here. You end up with something, let's see here, plus 4. So it's going to be about here. Slope of 2/3 looks kind of like this. This one's going to be solid. And it says y is less than 2/3. So which way is y less than? Well, that's going down. So it's shaded like this. Again, we're going to do some more practice of this, but I just kind of want to warm you up with the idea. Okay, part B of this. Suppose an ordered pair is not a solution of this. Must it be a solution of, again, so it's y greater than x plus 10. Must it be a solution of this one? You would think, oh yeah, it's going to be on the other side of the line, with one exception. What if it is exactly on the line of y equals x plus 10? So that means, notice here, this has the greater than, the less than, but neither has an equal portion. So if it's directly on the line, right, that we dash when we put in there, then not necessarily, right? Now, if we did have an equals part, then that would totally change the discussion. So, okay, so straight out of your book here, the graph of a linear inequality in two variables consists of all points in the coordinate plane that represent solutions. So the graph is called a region, is a half plane that is bounded by a line. All points on one side of the boundary line are solutions, while all points on the other side are not. So here's this graph. Y is greater than 3/2 x minus 1. So here's the line itself. Notice we dash it in. And then we say which way is y greater than? That's going up because y gets bigger going up. So we shade this half of the graph. And again, half plane is what we call that. Anything over here, not a solution. Anything on the line itself, technically technically not a solution because the line itself is not a solution because there's no equal parts here. Now if I go over here and we have y is less than or equal to negative 3 halves x plus 1. Again, here's the graph of the line itself. This time it's solid because of the equals part. And you look at the less than part, which way is y is less than? Y is smaller going down, so I shade this half, this half plane. Anything over here, not a solution. You can try it, you can plug it in, it doesn't work. Now, as I've already hinted at, graphing an inequality in two variables, what is the graph of this? Y is greater than x minus 2. Now again, there is no equals part, it's just greater than. So we graph the dashed line of y is greater than x, or y is equal to x minus 2, right? Instead of a solid line. And then we ask ourselves, which way does y get bigger? Well, if I look at the y-axis, y gets bigger as I go up, so I shade the upper half plane. Okay, and here nice and yellow, much prettier than I do. And again, is something a solution, right? You can double check it. And I always have you guys do this. When I say check this, check one on the line, check one above the line, check one below the line. Random points that are easy, by the way, to plug into, ones like this. And this one, pretty straightforward. Don't pick like 2.475, something weird, make your life more difficult. Now, when a linear inequality is solved for y, again, the direction of the inequality symbol determines which side of the boundary line is shaded. If the symbol is less than or equal to, shade below the line. If the symbol is greater than or equal to, shade above it. Sometimes you must first solve an inequality for y before using this method. So in other words, put it in slope-intercept form before you do that. Standard form won't do you any good. Point-slope form won't do you any good. So slope-intercept form tells you which way to graph. So by now I have an expectation that if you are given a line, or in this case, an inequality, in slope-intercept form, you can graph it without me having to explain where every part came from. So in this one, if I take a look, I've got a slope of 1/2, and I've got the point of 0, 1, right? That's the y-intercept. So I can graph it pretty easily. So I've got the point 0, 1 right here, and my slope then of 1/2, up 1 over 2, up 1 over 2. And you can back that up if you want to. Now here's the thing, you got to stop and ask yourself, is there an equal part of this? There is. So I can graph this with an equals, right? With an equal, so it's going to be a solid line, just like this. Where's it going? It's not graphing. Let's try that again. See if I can get it to graph. Interesting. It's not letting me graph. Just a second. Alright, so there you go. Anyway, there's the line. Now, as far as shading goes, which way is y getting smaller? That means we go down, right? So that means I shade the lower half plane. And boom, that's all there is. Now you get fancy and go along like that, but I don't care. So there you go. Don't just scribble in the middle. Make it really clear so I can tell. And pay attention to whether or not the line itself is dashed or filled in. Okay, so now graphing a linear inequality in one variable. Okay, it doesn't change. But we got to do some thinking. What is the graph of each inequality in the coordinate plane? So x is greater than -1. Okay, so here's what you got to ask yourself. And by now you better know what it means to graph x is equal to -1, right? So x, let's think about that. X is equal to -1. Now notice this does not have an equals part, right? So I graph it as a dotted line, and you can see that right here in my picture. A dotted line, x is equal to -1, right? There's -1, make a vertical line, but dotted because there's no equal portion here. Then you got to ask yourself, just like we do with the y thing, which way is x greater? Well, x gets bigger as we go to the right, so I shade the right half plane. Now again, I also expect that you know by now what y is equal to 2 looks like. So y equals 2 is obviously this horizontal line at y is 2. Notice again, right there, y is 2. And which way do I shade? Again, y gets bigger going up, so I shade upward, the upper half plane. And again, this is one of those things where kids kind of blow it. They don't spend the time learning the difference between these two graphs. And I expect by now that you do know that. Alrighty, so first one, A here, we're going to graph our own. X is less than negative 5. So what we're really graphing is X is equal to negative 5. And so we're going to ask ourselves, where is negative 5? And I apparently did not leave room on this one. So let's count by twos. when I grab it, that's funny. Let's count by twos. You know what, actually, I'm going to pause and I'm going to grab a different graph here. Just a second. Okie dokie, so there we go. Anyway, back to the matter at hand. We're technically graphing X is equal to negative 5, but as a dashed line because, right, it's less than. There's no equal portion to it up here. So again, when I look here, no equals part. Alrighty, so 1, 2, 3, 4, 5. It's going to be here. Okay, that's actually my line. And which way is y getting, or x, I'm sorry, getting smaller? Again, x is less than, going to the left. So I'm going to graph the left half plane. Over here I have y is less than or equal to 2. So what you're really going to graph is y equals 2. Well, y equals 2 is this horizontal line right here. Okay, and this time there's an equals portion here, so I did fill it in. Then you got to ask yourself, it says y is less than, all right, let's make sure I can read that there. There we go. Y is less than 2. So I'm going to shade. Which way is y getting smaller? Y gets smaller going down. So we shade rather the bottom half plane. Okay. Alrighty, fourth example, rewriting to graph an inequality. It says an interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owner can spend $420 or less. Write a linear inequality and graph the solution. What are 3 possible prices for the wallpaper and tiles? Now you will see problems like this on my quiz and on my tests. So tiled area, that's this part over here. 3 foot by 4 feet, right, so 12 feet squared. Papered area, 3 foot by 8 feet, 24 feet squared. And we said we're going to spend a total of $420. So you got to start thinking, okay, so, right, what's the cost of each type of material, so on and so forth. So let X is the cost per square foot of the paper. Y is this cost per square foot of the tiles. So 12 and 24 are the numbers we're going to be thinking about, right? Write an inequality and solve for Y. So we have $24, right, per square foot. 24 rather square foot, not dollars. Sorry, I messed up there. 24 square feet, that's the papered area, right? X the cost. 12 square feet is the size of the tiled area, again, times Y, which is the cost of square foot per tile. And again, the total cost is at $420. We can't spend more than that. That's what the less than equal to. Right up to it. Apparently, we live in magic no tax land. And so we solve. Again, we put it in slope-intercept form because it's easier to graph. So we graph this. That creates this line right here. And again, y is less than, so we shade the lower half. So paper and tile cost is the label, and we're looking for that kind of thing when you do your test and quiz. I do grade on labeling. Tile costs over here, right? And this is per square foot. Paper costs per square foot. And it says, so the graph only makes sense. That's other fun stuff too. We'll discuss that in a second. But again, this shaded area is the amount of each that you can get, right, in square feet. Or I'm sorry, in dollars rather, per the square feet. So you could buy, up to this many dollars worth. So it would be $35 per square foot for the tile, or up to 15.5 it looks like per square foot for the paper. And anywhere in between that's in the shaded area. If you spend more than that, you end up over here and not valid. Also, only the first quadrant makes sense because you can't spend negative dollars, right? Either direction. Okay, and we'll do one that. So it says 3 possible prices per square foot for wallpaper and tile are $5, $5 and $25, right? So $5 and $25 right up here. $5 and $15, right? So $5 and $15, that's another one because it falls in that yellow area. $10 and $10. $10 and $10. That fits right in there too. There's lots of others. So again, how many dollars you can spend per square foot. What that does is let you know, hey, I can only buy paper within a certain amount of money if I buy a more expensive tile. Also, tile is only sold in certain size boxes. This doesn't cover that, but it's kind of an important thing to think about for this a real problem. By the way, this is leading to later on what we call mixture problems. Loads of fun. And where we get to decide, okay, what are my possible combinations in and out? But not quite yet. We'll get there. Alrighty, so this problem here. It says for a party, you can spend no more than $12 on nuts. Okay, so before I even do anything, I know for sure what I'm going to write is going to be less than or equal to 12. That's where that comes from. Peanuts are $2 a pound. Cashews are $4 a pound. So I'm going to say let X equal, right? That's going to be pounds of peanuts, and Y is going to be pounds of cashews, right? Give it a pound sign. It's actually a pound sign, not a hashtag, people. Alrighty. So anyway, so I'm going to say 2x, right? So $2 per pound times number of pounds of peanuts plus 4y, again $4 a pound times number of pounds of cashews, has to be less than or equal to $12. I'm going to graph this using the zeros, and I certainly hope by now you know what that means. I'm going to plug in 0 for x and 0 for y, and we're going to generate those. And if I plug in 0 for x, I'm going to get 3 for y. If you don't believe me, you're welcome to work it out. And I'm going to get 6 for x when I plug in 0 for y. So my two zeros are 0, 3. And let's see, 1, 2, 3, 4, 5, 6, 0. And then we can just play connect the dots. And this one is going to be a solid line because it has that equals portion to it. So there we go. Not the best line, but hey, we'll give it a go. And then we have to decide which way to shade. Now here's the thing. Here's the thing. You need to translate that in slope-intercept form in order to do that. So we're going to, again, you can do it any way you want to here. Obviously subtract 2x, subtract 2x. So I have 4y equals negative 2x plus 12. I'm sorry, less than or equal to. There we go. Divide off my 4, divide off my 4, and y is less than or equal to negative 1/2 x plus 3. Look at that. That y-intercept 0, 3 did show up, didn't it? And again, y is less than or equal to, so I'm going to be shading down because y gets smaller going down. And it's only this part. I'm bound by the axes because it makes no sense for us to be in negative territory here. So it's literally only this chunk right here. And again, what points work? Well, you can put, certainly I've got two of them, right? 6, 0, 0, 3. And then you could pick anything in between. You could pick, I'd go right here and I'd go 1 pound of peanuts, 2 pounds of cashews. I could go 2 pounds of peanuts, 1 pound of cashews, right? You go one of each. You're still underneath, right? But if you want to maximize your money, you obviously have to look, where else you intersect. And I've included the answer key down below, so you can take a quick look at that. Just a second. There you go. It's graphed a little bit nicer than mine, but again, some possibilities there in front of you, and you can see the graph. So that's what you're looking for on that one. Alrighty, so writing an inequality from a graph. So what we're looking for on here, first off, you can write an inequality from a line. You'd better be able to by now anyway. Write an inequality from a line. Once you do that, if the line is solid, you include the equals portion, and you decide which way that y goes down, or if it goes down or up, and you shade accordingly. So here, the slope of the line is 2, right? So I know for sure I'm going to write something 2, right? Something 2x. The y-intercept is 1. We can see that right here. Y-intercept is 1. So it's going to be plus 1. And we got to decide, so it's going to be y something 2x plus 1. Now, we got to decide, is it shaded up or down? It is shaded down, so that means y is getting smaller, so it's going to be the less than, and again, the line is solid, so I get the equals portion. So, in this case, we find the answer is definitely A. So this one gives it to you without even giving you a graph, but it gives you a whole bunch of information. It says you are writing an inequality from a graph. The boundary line is dash. Okay, so that means for sure I don't have an equals part, right? It's dashed. And it has a slope of 1/3. So here's 1/3 x. Y is going to be over here. And a y-intercept of negative 2, so that's our minus 2. The area above the line is shaded. Well, if I think about shaded above the line, that means y is going upward. So that's going to be greater than. Again, not equals because it says the line is dashed. So that's what I'm going to write. That is something you definitely need to be able to do. Either look at a graph or just the general description here to be able to tell us that information.